Okay, let's get straight into 4.2. So they say over there that you must prove the following ratios. Okay, let's look at the letters that they give us. They say CM. Where CM? CM is here. So I'm looking at this one. CM divided by DC. CM DC. Okay, so that makes a nice triangle. So that's probably one of the triangles that I'm in. Not definitely, probably. Okay, and then AM. So I'm looking here. AM, which is this one, over AB, that one. So that's not a triangle. So those ratios didn't actually work out for me. Okay, so now I'm going to try and look across like this. AM is here, and CM is there. Okay, so there, that's nice. So that's probably one of the triangles that I'm in. And then I'm going to maybe look at another one. Let's do it like this. DC and AB. Where's DC? DC is here, and AB is here. Okay, so it's also not a triangle, right? But it's not a problem because we already know that DC and CB are the same thing. Okay, so if I say DC, I could also say CB and AB. Okay, so that is a triangle. Okay, so what did I just say? I said I could, instead of, so here we see DC there at the denominator. Instead of DC, you could say BC, because they are the same thing. We know that they are equal. That was given information to us. Okay, so let's maybe start by making that statement. So we are trying to prove these. Okay, so let's from now on, instead of that, we are going to say BC. Let's just put it there. We'll write it later on. We're going to need it later on, but let's write it later on. So those two triangles that we've highlighted, you need to prove that the two of them are similar. Okay, let's see, ACB, CMD. Okay, so we haven't proven those similar yet. Okay, so let's go ahead and let's say A2. Okay, A2, that's a 2, equals A1. Okay, so how do you know A2 is equal to A1? We've proven it in one of the previous questions. Okay, so we're not going to prove it again. Now we're just going to say, well, okay, that was proven previously. Okay, if you don't know where we've proven it, go watch the previous video. Okay, so we've proven it previously. We can also then say C1 and 2. Let's go with C1 and C2. C1 and C2. We can say that that is equal to B. Also, you don't have to reprove it. We've proven it. So you can say tan code because it's going to be based on previous things that we've done, tan code theorem. But we can also say proven because you have proven it before. And then similarly, you can tell me that M is equal to, what is it, ACB, which are both 90. And you can, again, we've proven it. So you can say proven, or you can even say given because they were given as 90. So angle, 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 there's your three angles. So now you are going to come up with the triangles that's similar. So when we did 4.1.2, that was nice because they gave us the order of the letters. Now you must come up with the order of the letters yourself, okay? So you're going to say triangle. Let's start with ABC, nice in order. ABC is similar to triangle. So now the order must match. A was equal to A. Okay, so it has to be A. Right, B was equal to C, so it has to be a C, and C was equal to M. A reason for similarity is angle, angle, angle. Okay, so this one I kind of just randomly came up with, and I came up with this one because I said A has to equal to A based on my information that I've come up with. I said that B has to equal to C based on what I've written above, and then similarly C has to equal to M based on what I've written above. Okay, so the order of the letters are exceptionally important because they help me come up with my ratios. Okay, so we'll say now therefore, I'm going to put it over here. Therefore, let's just, I want to see that. Okay, so I'm going to say AB divided by AC. So I'm saying the first two divided by first two would be the same as second two. So BC divided by CM. So that's going to be, let's do it like this. The second two and second two. And then it's also equal to first and last. So AC divided by first and last AM. So I have all of these ratios, and where did they come from? They came from my similarity. So I'm not gonna right down here, I could probably say similar triangles as my reason for my proportions, okay? But I don't have to say that because the proving is right above, okay? But let's leave the reason there for us now, okay? So let's see, we've got that. Now it's just it just requires some manipulation to kind of get it to look like what we want it to look. So you want CM and you want DC. CM, where do I have CM? I have CM over here. CM is there. And I need DC. Okay, DC was the one that we said we don't have, right? But DC and BC are the same. That's what we said over there. DC, BC are the same. So if I see BC, we can now go and replace that. Okay, so I guess we could write our ratios again to say that AB over AC is equal to DC instead of BC, okay, DC over CM, which is also equal to AC over, so I'm writing everything the same, just now in my ratio I have a DC instead of a BC. How can I do that? I can do that because we know that DC is equal to BC. That was given. Okay, so now we can replace that. So now, okay, let's go look again at what we have. Let's just zoom out a bit here quickly. So CM and DC, CM and DC, that's there. AM, AB, AM is here. AB, AB is here. Okay, so that's not going to be too tough. Okay, this is what we're going to do. We are going to use two parts. We always need two parts. So we're going to use these two, and we're going to come up with a certain ratio, and then we're going to use those two and come up with a certain ratio. Okay, so let's go ahead and do that. Let's just so I'm going to say DC divided by CM is equal to AC divided by AM. And now what I'm going to do is I'm going to multiply both sides with AM. So if I multiply both sides with AM, I'm going to write it here, but I'm going to erase it in a second. They will cancel out. Okay, so if I multiply both sides with AM, that cancels. Okay, and the AM would go to multiply here with the DC. So AM would go there. Okay, so I'm going to leave it in the form of AC equals. And the reason I'm doing that is because I see AC here and I see AC here. Okay, right, so I'm going to leave it as that. Then I'm going to look at these two and I'm going to write those down. So AB over AC. Maybe I want to take reciprocals here, but let's finish this first. DC over CM. Okay, so I want AC, which is over there, to be the subject. So I'm going to take reciprocals. I'm going to flip everything around. Okay, so I'm just going to erase this so that I can have AC as my subject. So it's AC divided by AB and CM divided by DC. Okay, so I still wrote these two. I just took the reciprocals of both of them. So now I'm going to multiply both sides with AB. So obviously that's going to cancel out, and here I'm going to have AB. Okay, let's get rid of that. So that's going to be gone. It's going to be, all right. So I have two expressions over here. So I have this expression and I have this expression, or equations, and both of them are in terms of AC. So obviously if both of them are AC, then they have to equal to each other. Okay, so let's write that over there. So we're going to say this is AM times DC divided by CM. Well, that has to equal to CM times AM divided by DC, because both of them were equal to AC. All right, now the rest of it is just some manipulation. So we're going to multiply both sides with a CM, so that's going to disappear, and this one is going to become a square. Okay, so that's gone now. The other one became a square, and then I'm going to multiply both sides with DC. So this one is going to become a square, and that one is going to disappear. Right, let's see, what do I still want? I want, in fact, I want the DC and the AB at the bottom. AB. All right, I made a mistake in coming up with these ratios. This one over here was supposed to be AB. Okay, yeah. Alright, so we had to multiply both sides with AB to get rid of that, meaning that this would be, let's erase this, this would be a B. Okay, so that's just a slight error. So we fixed it. Now we're going to divide both sides with our DC. So then DC squared will go there, and this one will disappear. Right, and then divide both sides with AB. AB will go there, and this one will disappear. Okay, so go through that. I know it was a bit tricky, but try and figure out exactly what we did. Spend time on that. Good luck.